The rest of the sections are word problems, and I made the functions really easy to work with to make it so that the math wasn't the thing that made it hard. It's just understanding the questions. And these aren't particularly hard. So I have question 21 on the screen, but I'm going to do 22. But if you want to, if you're not looking at the problems and you do them off the screen, this is the problem that you would be doing after I do problem 22. And then each of the next four problems, 21, 22, 23, and 24, I give a generic supply function and a price function. So if I read through problem 22, it says, suppose the number of units of a certain product that will be supplied, S is the number of units supplied at price P in dollars, is given by the equation S of P equals 3P minus 2. Let me teach you what this equation does. And in part A. Part A says how many of the units will be supplied. So the person that's wanting to sell this, if they can sell them for $1 each, whatever this product is, how many units will be supplied? That's what the supply equation can be used for. If I take a dollar amount and plug it into the supply equation for P, it's going to tell me how many units the supplier would make available for sale at that price. So if the price is $1, the supplier, the guy that's trying to sell these, would only make 1 unit available for sale. 1 unit. Again, so the numbers are really pathetically small and maybe not that realistic, but I didn't want the algebra to kind of get in the way of understanding. So this is super common. If you're a business major, you're guaranteed in some of your classes to see much more complicated supply equations that you can use to figure out how much of a product will be supplied at varying prices. The next equation is the demand equation. Just like the supply equation, basically the higher the price, the more of the product that's going to be available for sale, but maybe the less people are going to buy. So the S equation, this is the manufacturer, and the higher the price, the more the manufacturer is going to want to sell. But the D equation is the consumer. This is the demand equation. Of course, the lower the price, the more people are probably going to want to buy. The higher the price, the less people are going to buy. That's generally how demand works. As price goes up, demand goes down. Similarly, for the supply side, as price goes up, the supply goes up. When oil got super expensive recently, boy, lots and lots of people started fracking because higher the price, the more the supply. Now that oil prices and gas prices are going down, a lot of the people that opened up fracking, started doing fracking like in Oklahoma and Texas, well, they're not doing it. The supply is going to go back down because the price isn't high enough. So anyways, the demand equation works the same way. This says the demand for this particular product at price P is given by this equation. And then this asks the question in part B, how many units of this product will be demanded at a price of $1? Just going to use the demand equation, plug in 1 for P, and get negative 4 times 1 plus 12, which is going to be negative 4 plus 12, which is going to be 8. So if the price is $1, the sellers will only make 1 unit available, but the buyers want 8 of those. So it says at a price of $1, does supply exceed demand or does demand exceed price? Well, the demand is 8 units, the supply is 1 unit. Clearly, the demand exceeds the price. So there's a magic price called the equilibrium price, where the amount of the product that the producers will make available for sale equals exactly the amount of product that the people consuming it want. That's called the equilibrium price. And you find the equilibrium price by setting the supply equation equal to the demand equation. So to find the equilibrium price, that's the price where supply equals demand, you set the supply equation equal to the demand equation. And I'm going to solve this by adding 4p and adding 2 to both sides. When I do this, I get 7p equals to 14. I'm going to divide by 7. I'm going to divide by 7. I'm getting p, which is a dollar amount. It's not the quantity, it's a dollar. And the equilibrium price is going to be $2. So the answer to part D, the equilibrium price is $2. It says how many units of the product will be supplied at the equilibrium price. So if the price is $2, how many units are the supplier is going to make available? That's just plugging 2 into the supply equation, and I'll get 3 times 2 minus 2, which is 6 minus 2. So if the price is $2, the suppliers are going to make 4 units available. How many will consumers want? How many units will be demanded at the price of $2 or at the equilibrium price? Well, the demand at the equilibrium price is going to be negative 4 times 2 plus 12. That's negative 8 plus 12, and that's also 4 units. That's why it's called the equilibrium price, because the supply and demand are equal. So that's everything for number 22. I have 2 versions of these. I don't think I'm going to do a second one. So 21 is a problem that you should be able to do. It's exactly structured the same. There's a chance that you get a decimal. You might get a decimal answer for one of these. You might get like a point, like $3.50 for an answer for what that's worth, but that shouldn't be that big of a deal. So 21, pause. If you're working off the screen, you can pause and do this problem. And 23 is another problem that is exactly the supply-demand equation. Initially, I only had one of these written, and then I thought, oh, maybe that wasn't enough, so I just wrote another one up because I know I put this on the practice test, which means it's going to be on the test. And if you count, it has 6 parts. If something has 6 parts, it's probably going to be 12 points on the test, 2 points each. It's not particularly hard, but it's pointy. So go through these problems 21 and 23 before you move on. I'm going to skip problem 24, which is the same question, essentially, just with different functions. Used to be an accountant. I wasn't a terribly good accountant, didn't like it at all, but hence you'll see some business problems spill out as we go through some of the sections. There's a lot of business majors that take Math 151, so it's not a bad thing to see some really simple businessy problems that might help you in your business classes. And problems 25, 26, 27, and 28 are another group of 4 business word problems. I'll do problem 26 and leave you with 25 and 27. 26 talks about a company making a single product. And then it says the cost to make X units of this product can be found by this cost formula. Let's get used to using the cost formula by doing part A. This cost formula will tell me how much it costs to make X units of the product that they're making. Part A, find the cost of making 40 units of the product. It says the monthly cost to make X units of a product is given by this equation. So when I plug a number in, that's the number of units I'm making that month, and what I get out is how much it costs to make those units. When you get into a business class, this part, the 2x, is going to be called the variable cost. The 150 is going to be called the fixed cost. We don't need to get into that in an algebra class. We just need to be able to work the functions. And in part A, it's calling out this cost function, asking me to plug in 40 for the number of units, and x represents the number of units. And if I do the algebra, it will tell me that the cost to make 40 units for 1 month is $230. So this $230, it's the monthly cost. It's the cost to produce 40 of whatever these are, units, in a month. Again, I kept the numbers really small, not even bearing any connection to reality, just to keep the numbers easy. So that C of x represents the cost function. The next function is the revenue function. This function, r equals 4 over x, gives me how much money I'm going to take in, how much cash or sales I'm going to have from selling x units of that product. And that's what question B wants me to work with, just to get used to understanding the revenue function. It says find the monthly revenue earned by selling 40 units. I'm going to use the revenue function. This revenue function says the revenue from selling x units is 4 times x, or 4 times the number of units. So the monthly revenue from selling 40 units is 4 times 40, which is $160. So the revenue is $160. So the company's going to spend $230 to make the 40 units, and they're only going to generate $160 in sales. Question C says, is there a profit or a loss? Well, the difference between the cost of $240 and the revenue of $160, well, that tells me I'm going to have a loss, because the difference between the money I take in and the money I spend is my loss. So this company would lose $70. So we could either, for this, is there a profit or a loss? There's definitely a loss because the costs exceed the amount of sales. And then what is the cost or profit or loss? I can do this 2 ways. I could just say it's a $70 loss. And if I use the word loss, I usually don't put a sign. Or I can say there's a negative $70 profit, and that's another way to say that there's loss. It's not really a profit, it's a negative profit. A negative profit is a loss. If you put the number in as a positive, you just call it a loss. If you put it in as a negative, you say it's a negative profit, which is a loss. E wants me to find the break-even quantity. It's kind of like the equilibrium point. This is the break-even is when you don't make any money, you don't lose any money. It's just flat out zero, where your revenues equal your costs. How do we find the break-even quantity? Well, we just set revenues equal to cost. I'm going to set the revenue function equal to the cost function and solve for x. I'm going to subtract 2x from both sides and get 2x equals 150, and then divide both sides by 2, and I'm going to get x equals 75 units is the break-even quantity. And when I go to answer part E, the break-even quantity is 75 units. Now I might need a calculator. It says for part F, what's the cost at the break-even quantity? What's the cost at 75 units? Well, I use my cost function. I'm going to use the cost function to figure out the cost of making 75 units. I think I can do this without my calculator. But use your calculator if you don't want to do this in your head. So the cost of producing 75 units is $300. Part G, what's the revenue from at the break-even quantity of 75 units? Let me find the revenue at the break-even quantity of 75 units by plugging 75 in for x, and 4 times 75 is 300. And then what is the monthly profit or loss at the break-even quantity? Well, the difference between the revenue and the cost is the profit, and it's break-even, so the profit is 0, or the loss is 0. There's not a profit nor a loss at the break-even. This is exactly when you net out. Don't make a penny, don't lose a penny. So that's everything for 26. Just like the last problem on equilibriums, I have 2 problems for you to work, and I'm only going to do the one. I think it'd just kind of be redundant to do the same thing again. So try to do problem 25. And again, if I look at this, there's 3, 4, 5, 8 parts. It's probably 16 points on the test. And I'm pretty sure I put one of these on the practice test. So between the last 2 problems, the supply demand and this cost revenue, that's probably 28 points on the test. Would be my best guess. I haven't actually written the test, but I've written the practice test. 27 is your next one to practice. They should go real quickly. I have a problem 28, which is these guys again. I'm just not going to do it. I don't think I need to do 2 of these. One more style of problem. They're not particularly hard, but I didn't put these on the practice test, which means they're not going to be on the test, but I'll do them anyways. I made these numbers up too. I tried to get U-Haul cost numbers online, but then it wanted me to pretend I was booking a U-Haul and enter my email. I didn't want to do that, so I just made up numbers. So 30 says U-Haul charges $30 a day plus 75 cents for each mile driven to rent a certain truck. A says create a linear function that models the cost of renting a truck for 1 day. So for 1 day, I'm paying $30 per day plus 75 cents per mile. I need to come up with an equation written in function form that says the cost is 75 cents a mile plus $30 per day. That's easy. The cost is 75 cents per mile. I'm not going to write 75 cents. I'm going to write the decimal version of 75 cents to put it in dollar form. The cost is 75 cents per mile plus $30 if I'm just renting for 1 day. And let me come up with an equation for this. I'll say the cost C for the number of miles driven is 75 cents a mile plus $30. Okay. Question part B, what's the cost of renting a truck if it's driven for 200 miles? The cost of renting a truck for 1 day is $30 plus 75 cents a mile. So it's 75 cents times $200 for the mileage cost plus $30. I don't know, I can't do this. Second quit, clear. 0.75 times 200 plus 30, 180 bucks. So it would cost $180 if you're paying 75 cents a mile, which is huge because the 75 cents a mile times 200 miles is 150 bucks. Part C, suppose you spent $105 in a day. How many miles did you drive? If I put this on a test, there's a ton of students that would get the right answer without doing a lick of algebra. It's kind of the reason I'm not putting this on the test. So part C, if the cost, which is the left-hand side of the equation, is $105, how many miles did I drive? To solve that, simply just take the cost part of the cost equation and put the 1 day cost into it, set it into the equal to the cost equation, and then do my algebra. The algebra is going to be the minus 30 from both sides. And then divide by 75, or 75 cents. And then 75 divided by 0.75 gives me 100 miles. 100 miles. And this makes sense to me because if you drive 100 miles and you're paying 75 cents a mile, that's $75 for the miles plus another $30. 75 plus 30 is 105 bucks. 29 is your version of this problem. And oh, I can't tell what your other one is. I won't show the other one. I've got some numbering issues here. You'll see that I called this 29 again. Just do one of these. It's not on the test. It's not particularly hard. Good practice, though. You could theoretically see something like this in some other businessy class if you're a business major. So let's pause and call this section done.